Okay, question 1 of the paper 2. There are 964 pupils on the roll of a high school. It's forecast that the roll will decrease by 15% per year. What will be the expected roll after 3 years? Okay, right, okay, so we've got to take away 15%. Now the quick way to take away 15% is to multiply by 0.85. Think of 100, take away 15 and you get 85. Move the dot in twice, that's the quick way to get that. You've got to do it over 3 years, so you've got to take away 15% each year for 3 years. Quick way to do that is to the power of 3. Put that into your calculator and that's what your calculator says. It says give your answer to the nearest 10, so you get 592.0165 pupils. Nearest 10, that's going to be 590 to the nearest 10. Okay, on the paper question 2, and here it is here. The diagram shows a cube placed on top of a cuboid relative to the coordinate axes. A is the point 846. Now let's see, where's A? There it is there. 8 along, 4 back, 6 up. Okay, so we can now start putting in measurements here. That's 4, that's 6. An important thing here is that it's a cube. So a cube obviously has sides of the same length, so that's 4, that's 4, that's 4. This is going to help us get the coordinates of B and C. Now we need to find where B is. B is up at the top there. Okay, the coordinates are how you get from 0 to it, if you want to think of it that way. 8 along the X, 4 along the Y, and 6, and remember it's a cube, plus 4, 10. So B is 8, 4, 10. We now look for C, there it is there. Okay, how would you get from the origin to C? And that's its coordinate. Well, you would go, that's 4. With that being 8, you would go 4 along. You wouldn't go back along the Z at all. And you would go 6 and the 4 that we did earlier on. Same height as B, so that's going to be 4, 0, 10. On to question 3. 2 groups of people go to a theatre. Bill buys tickets for 5 adults and 3 children. The total cost of the tickets is £598.25. Write down an equation to illustrate this information. Well, the first thing you've got to do is actually write down what you're talking about. So A is going to be the cost of an adult ticket. C is going to be the cost of a child ticket. So with that, with those kind of rules, we can say that 5 adults and 3 children cost £158.25, and that's the equation to illustrate A. For part B, Ben buys tickets for 3 adults and 2 children. The total cost of his tickets was £98, so we can see that 3A plus 2C is 98. So we now have 2 equations there. And calculate the cost of a ticket for an adult and the cost of a ticket for a child. Basically we want to get A and C, and this is all about simultaneous equations. So I've rewritten them there for you. My method is just to get the C's to be the same number first of all. So I'm going to double this to make that 6, and I'm going to treble this to make that 6, sorry. So you have calculators here, so use a calculator even for sums that you might think you would get. 2 times 5A is 10A, add 6C, calculator out for that one, £316.50. 3 times 3A add 2C, 9A add 6C, 398, again use the calculator. Okay, so we have 2 equations and they're both 6C. Now I'd rather do 10 take away 9 because looking ahead that will give me 1A. So I'm going to multiply this equation here by minus 1. This will make minus 9A, take away 6C, it will just change the sign of everything there, minus 294, and you might notice that I've just copied that down here. This way I can see them right next to each other. 10A, take away 9A, basically you're adding minus 9A, but that just gives you A, plus 6C, add 6, minus 6C, they've gone. 316.50, take away the 294, again get your calculator out. So A is 22.50, so an adult ticket is 22.50, 22.50. One of the conditions is that 3 adult tickets and 2 child tickets cost 98, so we can use that. 3 adult tickets and 2 children cost 98. 3 times £22.50, £67.50. Add 2 children's tickets cost 98. Do a subtraction, and that's the cost of 2 children's tickets. Divide by 2, of course, using the calculator, and we get £15.25. So don't forget to actually write down the actual answer to the question, and that is that an adult ticket is £22.50 and a child's ticket is £15.25. And here we go, question 4. This is your standard deviation question. Okay, a runner has recorded her times in seconds for 6 different laps of running, and you can see them there. Calculate the mean of all these laps. Well, the mean is what you get when you add them all up and divide by how many there are. Now, of course, you've got a calculator, so there we have it there. You add them all up, press equals, and then you divide your answer by 6, and you get a mean of 56.5. Okay, and for part 2, calculate the standard deviation of these laps. Okay, now the standard deviation is one of these formulas that you may forget, but don't forget it's at the beginning of your question paper. There it is down there, it's down there at the bottom. Okay, that and the other one. Okay, so back to the question. We are going to get the standard deviation of these numbers. So the way I would do it is I would write all the numbers in turn there, and on this column here we're going to take each number and take away the mean, and after we've done that we're going to square it. So for instance, this number here is 53 take 56.25, work out what that is and then square it and you'll get 12.25. Similar story for 57, take away 56.5, square it, there we go. And it's the same process all the way down. Obviously none of these numbers will be negative because you're squaring things and you always get positives there. Get your calculator and you add them all up and you get 29.5. That is your sum of each number, take away the mean, squared, that we're going to use over here. So I've copied down one of the standard deviation formula that I'm going to use. There it is there. So the standard deviation is the square root of, and there we have it there, over n take 1. So we copy the 29.5 there. N is how many numbers there are. Now there are 6 numbers. Take away 1, you get 5. So 29.5 over 5 is 5.9, divided by 5, 5.9. Take the square root of it, and you get 2.4. And they're not telling you how to round it off, so I've made a decision to 1 decimal place. And there's the mean that I used earlier on. Over the page was, she changed her training routine hoping to improve her consistency after the change. She records her time to nothing laps, and the mean is 55 seconds and the standard deviation is 3.2. Has the new training routine improved her consistency? And this is the key thing. The consistency is how close the numbers are grouped together, and it's all about which one of these 2 sets of numbers has got the lower standard deviation. Okay, the standard deviation, as you can see here, is increased from 2.4 to 3.2. So her previous sets of results were more consistent because they were closer to their mean. So this has not improved her consistency for the reasons that you can see there. Okay, the standard deviation has gone up.